Question 4 asks us to find the exact value of the definite integral from -1 to 1 of x e to the modulus x dx. Well, the first thing you want to do is sketch this graph. Well, because you look at it and you see that it's very, very difficult to integrate this expression, x e to the mod x. Very difficult to integrate. So instead, let's have a look at the graph. And the graph shows us something very interesting. The graph is actually symmetric, kind of symmetric, in that if we flip this way, flipped this side onto the negative side, and then flipped it down, then we would get exactly the same curve. That means that this value here at 0.5 would be the same as this value here. The value at 0.5 is the same as the value at negative 0.5, except negative, right? As a corollary to that, it also means that this area under the curve here is going to be the same as the area under the curve here. So how can we express this? Determine the exact value of this. Well, this is the integral -1 to 1 of x e to the mod x dx. That's the same thing as the integral from -1 to 0 of x e to the minus x dx plus the integral from 0 to 1 of x e to the x dx. But if you look at this, right, these are going to be exactly the same. This goes from 0 to 1. This up here also goes from 0 to 1. The only difference is at the front. This one goes from 0 to 1. This one goes from -1 to 0. So actually this area, this is actually equal to negative of x e to the x dx plus x e to the x dx is equal to 0. So actually, this is just one example of a whole family of functions called odd functions. And what's special about odd functions is that if you have f of minus x, that's going to be the same as minus f of x, right? This is the defining characteristic. Why are they called odd functions? Well, because x to the power of any odd number is going to be an odd function. So for instance, x cubed, right? Let's f of x equal to x cubed, then f of minus x is equal to minus x cubed is equal to negative x cubed, right? So you can see we can just pull the minus out of the function, if you will. Another odd function that's quite famous is your sine of x function. Let f of x equal to sine of x. Then f of minus x is equal to sine of minus x is equal to negative sine of x. So we've known about this one for quite some time. So whenever we get an odd function and we're asked to integrate it about about an interval that's symmetric about the origin, then this function is going to evaluate to be 0. So this is just something for you guys to remember in case you run across them in the future.